On the morning of March 25, 1944, at precisely 09:30 hours, the Bay of Biscay lay grey and unsettled beneath a clouded sky. Captain Lieutenant Werner Henke, commander of U-976, stood tall in the conning tower of his submarine. Around him, his lookouts scanned the horizon with trained precision, their eyes cutting through the haze in search of danger. Henke felt confident. Beneath his feet lay 60 centimeters of seawater above the pressure hull, a shield that every German commander believed could stop any Allied shell should they be forced to crash dive. The doctrine was simple: disappear beneath the waves and you were safe. The sea was your armor. What Henke and his men did not know was that just beyond the horizon, 2 Royal Air Force Mosquito FB Mark 18 aircraft were approaching from the northeast. These were not ordinary bombers. They carried something new, something terrifying: 57mm Molins guns. These weren't weapons meant for rockets or depth charges. They were designed to do the impossible, to fire armor-piercing shells straight through the water, maintaining their lethal velocity even when a submarine tried to hide beneath the surface. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. For years, German naval training had taught the same lesson. The ocean was a wall of protection. Water's density would sap the energy from any projectile within centimeters. A meter of seawater was considered stronger than steel plating. But this morning, near the French port of Saint-Nazaire, that belief would be shattered forever. Flight Officer Turner, piloting Mosquito HX-903, adjusted his altitude, aligning perfectly for an attack run. His navigator, calm and practiced, monitored their angle and speed. The British had tested this maneuver for months, perfecting every calculation. Now, all of that preparation would be unleashed against U-976, a submarine crew with no idea their doctrines were already obsolete. The story of how this weapon came to exist is itself a testament to British ingenuity born from desperation. In the early months of 1943, Coastal Command faced a deadly problem. German U-boats, after suffering devastating losses from Allied aircraft throughout 1942, had changed their tactics. Instead of diving at the first sight of an aircraft, they were now staying on the surface, bristling with anti-aircraft guns. Their new 20mm and 37mm flak weapons were tearing Allied patrol aircraft from the sky. The Beaufighters and Wellingtons that had once dominated the Bay of Biscay were now being shot down in alarming numbers. Something had to change. The Royal Air Force needed a weapon that could strike at U-boats from beyond the range of their defensive fire. Rockets were tried, but their accuracy was abysmal. Only 5% of rocket attacks resulted in hits. Depth charges required the aircraft to fly directly over the submarine, making them easy targets for the upgraded German flak crews. In a windowless office in Peterborough, England, a solution was taking shape that no one could have predicted. The Molins Machine Company Limited, a firm that had spent decades perfecting the automated manufacture of cigarettes, had been approached by the Ministry of Supply. Their expertise in rapid, precise mechanical feeding systems made them ideal candidates for an unusual project. Could they adapt their cigarette manufacturing machinery to automatically feed shells into a naval gun? The request seemed absurd. Yet by mid-1942, Molins engineers had successfully created an autoloader for the Royal Navy's 6-pounder gun, allowing motor torpedo boats to fire 6-round bursts at a rate of 1 shell per second. The system worked flawlessly. Royal Navy vessels, equipped with the Molins autoloader, were devastating German E-boats and coastal convoys in the Channel. Someone at the Air Ministry asked a logical question. If the Molins system could work on a small, fast-moving boat pitching in heavy seas, could it work in an aircraft? The idea of mounting a 57mm anti-tank gun in a fighter bomber seemed mad. The 6-pounder weighed over 700 pounds. Add the Molins autoloader, ammunition feed system, strengthening for the airframe, and you were looking at over 1,500 pounds of additional weight. The recoil alone could tear an aircraft apart, But the de Havilland Mosquito was not an ordinary aircraft. Built almost entirely of wood, it was already one of the fastest, most versatile aircraft in the RAF inventory. Its twin Rolls-Royce Merlin engines gave it enough power to outrun most German fighters. Its wooden construction meant it could absorb punishment that would cripple an all-metal aircraft. And crucially, its nose had space. The standard Mosquito FB Mark VI fighter bomber carried four 20mm Hispano cannons in the belly and 4.303-inch Browning machine guns in the nose. In February 1943, a standard production Mosquito FB Mark VI was pulled from the assembly line at the de Havilland factory. Engineers removed the four Hispano cannons entirely. The space they vacated would house something unprecedented. The 6-pounder Molins gun, officially designated the quick-firing 6-pounder Class M Mark I with autoloader Mark III, was a masterpiece of improvised engineering. Based on the long-barreled 50-caliber variant of the standard Army anti-tank gun, it featured a fully automatic feed system containing 25 rounds. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. The installation was offset from the aircraft center line by 4 degrees to accommodate the large shells. The big gun protruded from beneath the nose like the stinger of some enormous insect. The 4.303 Browning machine guns were retained, mounted above the cannon bay. Their purpose was critical. The pilot would use the tracers from these smaller guns to aim the massive cannon. Where the Brownings pointed, the 6-pounder would follow. But mounting the gun was only part of the challenge. The forces involved were extraordinary. Each 57mm shell weighed 6 pounds and left the barrel at 2,950 feet per second. The recoil generated by firing this weapon was equivalent to hitting a brick wall at high speed. To prevent the entire aircraft from shaking itself apart, de Havilland engineers had to reinforce the entire forward fuselage with additional structural members. The nose section was rebuilt 3 times before they found a configuration that could withstand repeated firing without cracking. The first test flight took place on June 8, 1943. Test pilot Geoffrey de Havilland Jr. took the modified Mosquito up over the Welsh coast. The ground firing tests had been promising. On paper, the weapon system worked, but would it survive the stresses of flight? The first live fire test was scheduled for 2 weeks later. Engineers had mounted the aircraft with strain gauges and accelerometers to measure every vibration, every stress point. On June 23, 1943, with observers watching from the ground, the test Mosquito dove toward a target barge floating off the Pembrokeshire coast. The pilot aligned his shot using the Browning tracers, then squeezed the trigger. The cannon roared. The first shell tore across the water and struck the barge dead center, punching completely through both sides. The Mosquito shuddered violently but held together. The pilot fired again and again. Five shells in rapid succession, each one finding its mark. The accuracy was astounding. Against tank-sized targets, the Molins-equipped Mosquito achieved a 33% hit rate. Compare that to the 5% hit rate of rocket projectiles, and suddenly the enormous expense and complexity of the system seemed justified. But there was a catch. The gun would only function properly during a very specific attack profile. The pilot had to begin at 5,000 feet altitude, then enter a 30-degree dive. Any deviation from this angle, any attempt to maneuver while the gun was firing, would cause the autoloader to jam. This created a terrifying problem. To successfully attack a U-boat with the Molins gun, a Mosquito pilot would have to commit to a long, steady dive directly toward his target. For almost 18 seconds, the aircraft would be flying in a perfectly predictable trajectory, unable to maneuver, while German gunners below fired everything they had at him. It was the aerial equivalent of walking into a firing squad. The crews who would fly this weapon needed to be either exceptionally brave or slightly mad, possibly both. By October 1943, 18 Mosquito FB Mark VIs had been converted to carry the Molins gun. The new variant was officially designated the FB Mark 18, but among the crews who would fly it, another name took hold: tsetse, named after the African fly whose bite transmitted sleeping sickness. The nickname was perfect. Like its namesake, the tsetse mosquito carried a sting far more lethal than its size suggested. The first 3 tsetse aircraft were delivered to No. 618 Squadron in late 1943, but were quickly reassigned to No. 248 Squadron of Coastal Command at RAF Predanak in Cornwall. This squadron had been flying anti-shipping and anti-submarine missions from the southwestern tip of England since 1942. They knew the Bay of Biscay intimately, they knew its moods, its dangers, and most importantly, they knew where the U-boats travelled. Squadron leader Tony Phillips, the commanding officer of the special detachment that would operate the tsetse aircraft, gathered his pilots for their first briefing in late October. The room fell silent as he described the weapon they would be using. Many of the pilots had flown Beaufighters and knew the terror of making low-level attacks against heavily defended targets. Now they were being asked to do something even more dangerous: fly a steady, predictable dive for 18 seconds while U-boat gunners tried to knock them out of the sky. But Phillips also explained the opportunity. Intelligence reports indicated that U-boats were increasingly fighting it out on the surface. They had been told by their own commanders that the new anti-aircraft armament made them safe from air attack. The Germans were confident, overconfident, and confidence, Phillips explained, was a weakness that could be exploited. The first operational patrol took place on October 24, 1943. 2 tsetse mosquitoes, accompanied by 4 standard FB Mark 6s for fighter cover, swept out over the Bay of Biscay. The weather was poor, visibility limited. They found nothing. The same pattern repeated for the next 2 weeks. Long patrols, high tension, no contact. Some of the pilots began to wonder if the elaborate weapon system was nothing more than an expensive experiment. Then, on November 7, 1943, everything changed. Flight Officer Turner, the same pilot who would later attack U-976, spotted a surfaced U-boat 20 miles northwest of the Spanish coast. The submarine was traveling at high speed on the surface, racing to reach the safety of its base before dawn. Turner nosed his Mosquito into the prescribed 30-degree dive. His navigator called out altitude and speed: 5,000 feet, 4,000, 3,000. The submarine's flak guns opened up, tracer rounds, arcing toward them like deadly fireworks. Turner held the dive steady, his thumb hovered over the firing button. 2,500 feet. The submarine filled his gun sight. He pressed the button. The Molin's gun hammered out a burst of 3 shells. Massive plumes of water erupted around the U-boat. 1 shell struck the conning tower, sending a shower of metal fragments across the deck. The submarine's flak guns went silent. Turner pulled out of his dive, his Mosquito clawing for altitude. The U-boat crash-dived immediately, disappearing beneath the waves. Turner circled, searching for oil slicks or debris. Nothing. The submarine had escaped. But it was damaged, badly damaged. The after-action report noted that while no kill could be confirmed, the tsetse had proven it could hit a submarine. More importantly, it had survived the attack. The gun worked, the aircraft held together, the doctrine was sound. Word spread quickly through the U-boat pens along the French coast. German intelligence officers interrogated survivors from merchant ship attacks, pieced together reports from coastal observers, and compiled a troubling picture. The Allies had a new weapon, a wooden aircraft armed with a massive cannon that could punch through a submarine's hull even underwater. Some U-boat commanders dismissed the reports as Allied propaganda. Others weren't so sure. Captain Lieutenant Werner Henke was one of the skeptics. By March 1944, Henke had been hunting Allied convoys for nearly 4 years. He had survived 37 combat patrols, sunk 11 Allied merchant ships, and earned the Knight's Cross with oak leaves. He knew submarines, he knew their strengths and their limitations, and he knew that the sea was the ultimate protection. A metre of water, he had been taught at the Submarine Academy in Kiel, would stop any shell. The density of water was simply too great. Physics didn't lie. 20 minutes earlier, Henke's hydrophone operator had reported multiple aircraft engines approaching from the north. This was routine. Allied patrol aircraft were constantly sweeping the Bay of Biscay. The standard procedure was simple: man the flak guns, prepare to dive if necessary, but fight if you could. U-976 had been fitted with upgraded anti-aircraft armament just 2 weeks earlier during a brief stop at the submarine pens in Saint-Nazaire. Twin 20mm flak guns, plus a brand new 37mm cannon. These weapons had saved U-boats before, forcing Allied planes to break off their attacks or paying for their persistence with their lives. But today would be different. Turner and his wingman, Flight Officer Hilliard in Mosquito MM425, had been searching for targets since dawn. They were part of a larger strike package. 4 standard Mosquito FB Mark 6s provided top cover, ready to engage any Luftwaffe fighters that might appear. The 2 Tsetse aircraft flew lower, their eyes scanning the grey waters below for the telltale wake of a submarine. At 09:23 hours, Turner's navigator spotted something, a dark shape moving through the water, leaving a white V-shaped wake. Submarine, bearing 045 degrees. Turner banked his Mosquito toward the target, simultaneously calling out the sighting to the other aircraft. The escort Mosquitoes moved to higher altitude, ready to suppress any flak fire from nearby German vessels. On the conning tower of U-976, the lookouts finally spotted the approaching aircraft. Their shouts cut through the morning calm. "Mosquito bearing 045, flak cruise." Henke's hand went instinctively to the diving alarm, but he paused. The aircraft was still far away, high altitude. Perhaps it hadn't seen them. Perhaps they could slip beneath the waves before it got close enough to attack. Then he saw the second Mosquito, and the third, and the fourth. 6 aircraft total, all converging on his position. This wasn't a patrol. This was a coordinated strike. His hand slammed down on the diving alarm. The harsh klaxon shrieked through the submarine. Men scrambled through hatches. The flak crews remained at their posts, traversing their guns skyward. Turner tilted his Mosquito into the attack dive. 30 degrees, airspeed building rapidly. The wooden aircraft dropped like a hawk toward its prey. 5,000 feet, 4,500. The submarine's flak guns opened fire. Tracers arced up toward him, bright against the grey sky. His navigator's voice was calm in his headset. "Steady, steady, 3,000 feet." Turner's twin Browning machine guns opened fire, sending a stream of .303 tracers skipping across the water. The small bullets splashed harmlessly around the submarine but gave Turner his aim point. Where those tracers hit, the 57mm shells would follow. His right hand moved to the firing button. 2,500 feet. The submarine was growing larger in his sight. He could see men on the conning tower, see the muzzle flashes from their anti-aircraft guns. He pressed the button. At 09:37 and 12 seconds, the first 57mm shell tore free of the Molin's gun. The Mosquito shuddered as if it had struck an invisible wall. The recoil was enormous, but the airframe held. Turner kept the button pressed. The autoloader cycled. Another shell fired. Then another. 5 shells in rapid succession, each one a 6-pound projectile of hardened steel screaming through the air at nearly 3,000 feet per second. Inside U-976, chaos erupted. The diving alarm was still shrieking. Men were still scrambling through the interior hatches, sealing compartments as the submarine tilted downward. The diesel engines had been shut down, electric motors engaged, the bow planes angled to take them deeper. Henke watched from the conning tower as the sea began to rise around him. Another few seconds, and they would be underwater. Safe. Protected by the density of the ocean itself. The first shell hit the water 20 meters ahead of the submarine's bow. Most shells, when they strike water at high velocity, tumble violently and lose most of their energy within meters. But the 57mm armor-piercing shells fired from the Molin's gun had been specially designed, longer than standard anti-tank rounds, with precisely calculated weight distribution. they maintained stability underwater. The velocity dropped from 2,900 feet per second to about 2,000 feet per second, but it was still more than enough. The shell slammed into the forward section of U-976 with a sound like a massive hammer striking sheet metal. The impact point was near the forward torpedo room, where the pressure hull was thickest. It didn't matter. The shell punched through as if the steel were paper. Water exploded inward under tremendous pressure. 2 men in the forward torpedo room died instantly, torn apart by steel fragments and the incoming sea. Others were thrown against bulkheads as the ocean roared into the confined space. A second shell struck amidships, penetrating the control room. Seawater and hydraulic fluid sprayed across the gauges and instruments. Navigation charts dissolved into sodden pulp. Officers struggled to keep their footing as the deck tilted at a crazy angle. Henke's voice cut through the chaos, ordering ballast tanks blown. Emergency surface procedures. But even as he gave the orders, he knew. Their sanctuary had failed them. The sea was not armor. It was no protection at all. Above, Turner pulled his Mosquito out of the dive, the twin Merlin engines screaming as he clawed for altitude. His wingman, Hilliard, was already rolling into his own attack dive. Though U-976 was mortally wounded, Hilliard pressed home his attack. 2 more 57mm shells tore into the submarine at just 15 meters depth. Compartments that were already flooding buckled further. The hull, designed to withstand pressure from outside, could not withstand this internal violence. By 0942 hours, less than 7 minutes after the attack began, U-976 was finished. 38 of her 52 crewmen were dead, trapped in flooded compartments or killed by shell fragments. 14 survivors clawed their way to the surface through the forward torpedo hatch, gasping for air amid a spreading slick of oil and debris. Above them, the Mosquitoes circled, their radios calling in positions for rescue craft. For the victorious pilots, this was another mission complete. For the Germans floating in the cold waters of the Bay of Biscay, it was the end of certainty. The loss of U-976 sent shockwaves through the Kriegsmarine. This wasn't a lucky hit from a depth charge. This wasn't a rocket attack that had somehow found its mark. This was something fundamentally different. An aircraft armed with a cannon that could kill submarines beneath the waves. The crash dive, the maneuver that every U-boat captain trusted as their ultimate escape, no longer guaranteed safety. The rules had changed. Within days, the story spread through the U-boat pens at Lorient, Saint-Nazaire, and Bordeaux. In the cramped ready rooms where crews waited between patrols, men spoke in hushed tones about wooden hammers that could smash through steel hulls. Some claimed the British had developed a new type of shell that could home in on submarines like the acoustic torpedoes the Americans used. Others insisted it was impossible, that the reports were exaggerated or fabricated by Allied intelligence to spread fear. But the survivors of U-976 told a different story. They described the Mosquito's dive, the steady, unwavering approach, the terrible sound of shells punching through the hull while they were already submerged, the speed with which their boat had flooded and died. These were not the words of men repeating propaganda. These were the testimonies of sailors who had watched their sanctuary become their tomb. Commander Karl Dönitz, head of the U-boat fleet, received the intelligence reports with growing concern. The loss of U-976 was troubling enough. But what alarmed him more was the trend. Over the past 6 months, U-boat losses in the Bay of Biscay had been climbing steadily. The decision to have submarines fight it out on the surface with anti-aircraft guns had initially seemed sound. In the summer of 1943, several Allied aircraft had been shot down by U-boat flak crews. But by spring of 1944, the equation had shifted. The Allies were adapting faster than the U-boats could. The Molins gun was just one adaptation. There were others. Improved radar that could track submarines in heavy seas, better torpedoes that could be dropped from aircraft, coordinated attacks using multiple aircraft with different weapons. But the Molins gun represented something psychologically devastating. It struck at the one belief that every U-boat crew held sacred, that beneath the waves, they were safe. If you find this story engaging, Please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. For the crews of No. 248 Squadron, the sinking of U-976 was vindication. The months of training, the expensive development program, the risk of flying that terrifying attack profile, all of it had been worth it. The Tsetse could kill submarines. More attacks followed in the weeks after March 25th. On June 6, 1944, as Allied forces stormed the beaches of Normandy, Tsetse mosquitoes attacked U-212 northwest of Brest, damaging her so severely that she had to abort her patrol. On June 10, U-821 was pounded by repeated Molin's gun attacks until her crew abandoned ship. A Liberator bomber from No. 206 Squadron arrived shortly after to finish her with depth charges. But these successes came at a cost. The Tsetse aircraft were vulnerable during their long attack dives. German flak crews learned to concentrate their fire on the diving aircraft, knowing they couldn't maneuver. In June 1944, Mosquito HX-903, one of the original 3 Tsetse aircraft, the very plane that had participated in the sinking of U-976, crashed after colliding with another aircraft while returning from patrol. The pilot, who had struck the decisive blow against Henke's submarine, did not survive to see the war's end. The tactical challenges were enormous. Yes, the Molin's gun could penetrate a submarine hull, but hitting a submarine with a 57mm shell from a diving aircraft required extraordinary skill and nerves of steel. The pilot had to begin his dive at precisely the right altitude and angle, hold that dive steady despite flak fire, time his shot to account for the shell's trajectory through both air and water, and do all of this while flying an aircraft that couldn't maneuver without jamming the very weapon he was trying to fire. Moreover, submarines remained elusive targets. By mid-1944, German U-boats were spending less time on the surface. New snorkel breathing devices allowed them to run their diesel engines while submerged at periscope depth. Radar warning receivers alerted them to approaching aircraft long before visual contact. The Bay of Biscay, once a killing ground for U-boats, was becoming a no-man's land where neither side held a decisive advantage. The Tsetse mosquitoes found alternative targets. German coastal convoys proved far more vulnerable than submarines. Merchant vessels, minesweepers, and escort ships couldn't dive beneath the waves. They could only rely on their anti-aircraft guns and hope to drive off their attackers. Against these targets, the Molin's gun was devastating. A single 6-pound shell could punch through a ship's hull below the waterline, flooding engine rooms and cargo holds. Even the so-called sparebreaker vessels, converted merchant ships with hulls reinforced by concrete to sweep mines, proved vulnerable to direct hits from 57mm armor-piercing shells. The most remarkable engagement came on March 10, 1944, just days before the sinking of U-976. 6 Mosquitoes from No. 248 Squadron, including 2 Tsetse aircraft, intercepted a German convoy off La Palisse. The convoy consisted of U-960 and 4 M-class minesweepers, plus 2 sparebreaker vessels. All of them bristled with anti-aircraft weapons. Providing air cover were 10 Junkers Ju-88 twin-engine fighters. The battle that followed was chaos. The standard Mosquito FB Mark 6s engaged the Ju-88s, their 20mm cannons tearing into the German fighters. 2 Ju-88s went down immediately. A third made the fatal mistake of crossing in front of squadron leader Phillips's Tsetse aircraft. Phillips didn't hesitate. He triggered the Molin's gun. A single 6-pound shell struck the Ju-88 in the wing root. The German fighter disintegrated in mid-air, torn apart by the massive impact. It was possibly the only time in the war that an aircraft-mounted anti-tank gun shot down an enemy fighter. Meanwhile, the convoy below erupted in a storm of flak. Tracers from dozens of guns created a curtain of fire. The Tsetse mosquitoes dove through it, their pilots committed to their attack runs. Shells from the Molin's guns slammed into the minesweepers, punching through armoured bridges and deck plating. U-960 took multiple hits and had to be abandoned. Though the submarine was later recovered and towed to port, she never sailed again on a combat patrol. The engagement demonstrated both the Tsetsie's potential and its limitations. Against heavily defended targets, the losses could be catastrophic. By September 1944, No. 248 Squadron relocated to RAF Banff in Scotland. They became part of the famous Banff Strike Wing, a multi-squadron formation dedicated to attacking German shipping in Norwegian waters. The Tsetsie aircraft went with them, though by this point their role had evolved. They were no longer primarily anti-submarine weapons. Instead, they functioned as precision strike aircraft, capable of knocking out specific targets that conventional rockets and bombs might miss. The Banff Wing operations were some of the most dangerous missions of the war. German convoys hugging the Norwegian coast travelled through narrow fjords where Allied aircraft had little room to manoeuvre. Luftwaffe fighters based in Norway provided constant air cover. German flak ships, specifically designed to defend convoys, carried an astonishing array of anti-aircraft weapons. Yet, the Mosquitoes of the Banff Wing, including the Tsetsie aircraft, pressed home their attacks with courage that bordered on recklessness. On April 5, 1945, with the war in Europe entering its final month, Mosquitoes from the Banff Wing attacked a German surface fleet in the Kattegat Sound between Denmark and Sweden. The engagement was fierce. German destroyers and escort vessels put up a wall of defensive fire. But the Tsetsie aircraft, diving through the flak, scored multiple hits. 2 German vessels were sunk, others damaged. It was one of the last great surface actions involving the Molins-equipped Mosquitoes. Yet even as these dramatic engagements unfolded, the Tsetsie's days were numbered. The Royal Air Force had made a strategic decision. The Molins gun, for all its innovation and striking power, was too specialized, too difficult to maintain, too vulnerable during its long attack dive, and most critically, it couldn't be easily removed or refitted. A standard Mosquito FB Mark VI could be armed with bombs, rockets, or drop tanks, depending on the mission. A Tsetsie could only carry its massive gun and 25 shells. The versatility wasn't there. In February 1945, No. 248 Squadron began transitioning away from the Tsetsie aircraft. The remaining FB Mark 18s were transferred to No. 254 Squadron at RAF North Coats, where they operated until the end of the war in Europe in May 1945. Some were used in the final weeks to hunt German Biber midget submarines operating in Dutch coastal waters. The results were mixed. Midget submarines were small, difficult to spot, and rarely surfaced long enough for an effective attack. After VE Day, the Tsetsie Mosquitoes were rapidly withdrawn from service. Most were scrapped. A handful survived long enough to be used in gunnery trials and engineering studies. The RAF briefly experimented with an even larger weapon, the 32-pounder gun mounted in a Mosquito, but abandoned the project when tests revealed that the recoil would likely destroy the airframe after just a few shots. The final accounting of the Tsetsie's war record is modest compared to the ambitious goals that had driven its development. 1 confirmed, U-boat sunk, several more damaged, numerous surface vessels attacked with varying degrees of success. 1 Ju-88 fighter shot down in the most unlikely aerial combat engagement of the war. About 27 to 30 aircraft built, several lost to enemy action or accidents. Dozens of pilots and navigators who had flown the most unusual and challenging weapon system of coastal command. But numbers alone don't capture the Tsetsie's true significance. What it represented was more important than what it achieved. It demonstrated that even in the darkest days of the Battle of the Atlantic, British engineers and designers were willing to try anything, no matter how unconventional, to gain an edge over the U-boats. It showed that the cigarette manufacturing machinery of peacetime could be transformed into the instruments of war. And most critically, it proved that the ocean was no longer the impenetrable sanctuary that submarine crews had believed it to be. For Werner Henke and the 37 other men who died aboard U-976 on that grey March morning, the Tsetsie represented the end of an era. The era when diving meant safety, when the sea was armour, when physics and training and doctrine all promised that beneath the waves you were untouchable. That promise died with them, shattered by 57mm shells that punched through both water and steel with equal contempt. In the decades since the war, the Tsetse Mosquito has become a footnote in aviation history, overshadowed by more glamorous fighters and bombers, forgotten in favor of the standard Mosquitoes that served in countless roles with distinction. Yet for those who study the evolution of anti-submarine warfare, the FB Mark 18 remains a fascinating example of innovation under pressure, a weapon system that probably shouldn't have worked, but did. A marriage of industrial machinery and military necessity that produced something utterly unique. Today, no Tsetse Mosquitoes survive. The few that made it to the end of the war were scrapped in the post-war drawdown. All that remains are photographs, technical drawings, and the memories recorded in after-action reports and pilot memoirs. And scattered across the floor of the Bay of Biscay, slowly being consumed by rust and sea creatures, lie the shattered hulls of U-boats like U-976, silent monuments to the day when the rules of submarine warfare changed forever. The Molin's gun itself continued to serve after the war in other applications. Motor torpedo boats retained their rapid-fire 6-pounders for years. Some anti-tank guns equipped with Molin's autoloaders saw service in post-war conflicts. The principle of automated feeding systems, pioneered by the cigarette manufacturing machinery of Peterborough, eventually influenced the development of automatic cannons used on modern armoured vehicles and aircraft. But the idea of mounting such a weapon in a wooden aircraft, requiring pilots to fly a perfectly steady dive for 18 seconds while being shot at, asking them to strike targets through water with artillery designed for use on land, that particular combination of audacity and desperation never appeared again. The Tsetse was a weapon born from a specific moment in history, when the U-boat threat was existential, and any solution, no matter how improbable, was worth attempting. For the survivors of U-976, rescued from the cold waters of the Bay of Biscay and sent to prisoner of war camps in England and Canada, the experience marked them permanently. They had been taught that German engineering was superior, that U-boats represented the pinnacle of naval technology, that their training and tactics would carry them through any danger. And then they had watched all of that certainty crumble in 7 minutes of terror as wooden aircraft firing massive cannons tore their submarine apart beneath the waves. Some of them, interviewed decades later, still struggled to explain what had happened that morning. How could wood defeat steel? How could a cigarette machine's mechanics be turned into a weapon that changed naval warfare? How could the laws of physics they'd been taught simply stop applying? The answer, of course, was that physics hadn't changed, only their understanding of it. Water does slow projectiles dramatically, but not enough. Not against shells specifically designed to penetrate submarine hulls at ranges where the submarine believed it was safe. The psychological impact of the Tsetse on U-boat crews extended far beyond the handful of submarines it actually attacked. Word of mouth in the close-knit community of U-boat men ensured that stories of the wooden hammer spread quickly. In the bars and ready rooms of the submarine bases, crews traded rumours and speculation. Some claimed the British aircraft carried dozens of these massive cannons. Others insisted that the shells could somehow track submarines underwater. The truth, a single gun, 25 shells, fired from an aircraft that was as vulnerable as it was deadly, was almost anticlimactic. But it was enough. Combined with improved Allied radar, better depth charges, long-range patrol aircraft, and the breaking of German naval codes, the Tsetse contributed to an environment of fear and uncertainty that undermined U-boat effectiveness in the final year of the war. German submarine commanders who once would have stayed on the surface and fought now dove at the first sign of aircraft, and even underwater they knew they weren't truly safe. The Bay of Biscay, once the primary route for U-boats travelling between their bases in France and their hunting grounds in the Atlantic, became known among German sailors as the Death Corridor. So many submarines were lost in those waters that Admiral Dönitz seriously considered abandoning the French bases entirely and relocating operations to Norway. The Allies' dominance in the Bay of Biscay, achieved through a combination of technology and tactics, effectively cut off Germany's access to the Atlantic convoy routes. Among the many weapons and systems that contributed to this dominance, radar, long-range patrol aircraft, escort carriers, improved depth charges, acoustic homing torpedoes, the Tsetse Mosquito occupied a unique niche. It was, in many ways, a weapon of psychological warfare as much as a practical anti-submarine system. The knowledge that such a weapon existed, that crash diving no longer guaranteed survival, changed how U-boat commanders made decisions. And in warfare, especially in the confined spaces of a submarine under attack, decision-making under stress is everything. The handful of pilots who flew the Tsetse in combat developed an almost mystical reputation within coastal command. They were the men who had mastered the most difficult attack profile in the RAF inventory, who had learned to hold a steady dive while flak shells exploded around them, who had calculated the lead and angle required to hit a moving target through both air and water, who had returned from missions that should have killed them and lived to fly again. Flight Officer Turner, the pilot who had sunk U-976, continued flying Tsetse missions until his aircraft was lost in the collision in June 1944. His navigator survived the crash. Turner did not. He was awarded the Distinguished Flying Cross posthumously. In the brief citation that accompanied the medal, no specific missions were mentioned, just a note that he had shown exceptional courage and skill in attacking heavily defended targets. The specifics remained classified for years after the war. Squadron leader Tony Phillips, who had shot down the Ju-88 with the Molins gun in that bizarre air-to-air engagement, survived the war. He later wrote about his experiences flying the Tsetse, describing it as both the most capable and most terrifying aircraft he'd ever flown. The capability came from the gun's raw power and surprising accuracy. The terror came from the knowledge that once you committed to the attack dive, you couldn't maneuver. You were locked in. Either you completed your run and pulled out, or you died. The ground crews who maintained the Tsetse aircraft faced their own challenges. The Molins autoloader, for all its mechanical brilliance, was temperamental. It required constant adjustment and maintenance. Salt spray from operating over the ocean corroded the feed mechanisms. The tremendous recoil from repeated firing could knock components out of alignment, and if the gun jammed during a mission, there was no way for the pilot to clear it. He had to abort the attack and return to base with his ammunition unexpended. Armourers learned to treat each aircraft as individual. Some Tsetse Mosquitoes were temperamental, their guns jamming frequently. Others ran flawlessly, mission after mission. The reason for this variation was never fully understood. Identical aircraft with identical guns and identical ammunition behaved differently. Some pilots developed superstitions, refusing to fly certain aircraft. Others developed bonds with specific planes, requesting them for every mission. The shells themselves were works of precision engineering. Each 57mm armor-piercing round had to be manufactured to exacting tolerances. Too heavy, and it would lose velocity too quickly in the water. Too light, and it wouldn't penetrate the submarine's hull. The nose had to be strong enough to punch through steel, but shaped precisely to maintain stability when transitioning from air to water. British munitions factories produced tens of thousands of these specialized shells, most of which were never fired in anger. They remained in storage depots until they were eventually scrapped after the war. The logistics of supporting the Tsetse operation were considerable. Each aircraft required specialized tools and parts that couldn't be shared with standard Mosquitoes. The guns needed regular inspection and refurbishment. The ammunition had to be stored in climate-controlled magazines to prevent corrosion. Spare parts were scarce because production had been so limited. When a Tsetse was damaged, repairs often took weeks because replacement components had to be fabricated from scratch. All of this for a weapon system that, in the final analysis, sank one U-boat. It's tempting to view the Tsetse as a failure, an expensive, complicated solution to a problem that was being solved by other, simpler means. But that assessment misses the larger picture. The Tsetse represented British determination to pursue any advantage, no matter how unconventional. It demonstrated a willingness to take risks, to try unproven technologies, to push the boundaries of what was thought possible. And it worked, not perfectly, not consistently, but when it worked, it was devastating. The image of that wooden aircraft diving through flak, its massive cannon hammering shells through the water to strike at submarines that thought themselves safe. That image haunted German naval commanders for the rest of the war. They could never quite be certain that the next diving Mosquito wouldn't be a Tsetse. That uncertainty, that fear, had operational consequences. U-boats that dove prematurely couldn't attack convoys. Commanders who were overly cautious missed opportunities. Morale suffered when sailors believed their primary defensive tactic no longer guaranteed survival. The Royal Air Force learned valuable lessons from the Tsetse program that influenced post-war aircraft development. The importance of accurate, high-velocity guns over slower rockets. The need for weapon systems that could be integrated into multiple aircraft types rather than requiring dedicated variants. The challenges of asking pilots to fly predictable attack profiles against heavily defended targets. All of these lessons shaped the design of jet fighters and attack aircraft in the decades following World War II. Perhaps most significantly, the Tsetse proved that unconventional thinking could produce effective weapons even late in a war. By 1943, the basic technologies of World War II were well established, but combining those technologies in new ways, anti-tank guns with autoloaders from cigarette machines mounted in wooden aircraft could still yield surprises. This lesson wasn't lost on military planners. Innovation didn't require revolutionary new discoveries. Sometimes it just required looking at existing tools in new ways. The engineers at Molin's Machine Company returned to manufacturing cigarettes after the war. The specialized knowledge they'd gained developing autoloaders for military applications gradually faded as the men who'd done the work retired. The company itself eventually was acquired and absorbed by larger corporations. Today, few people remember that one of Britain's most unusual aircraft weapons was developed by cigarette machine manufacturers. The de Havilland Company continued producing Mosquitoes until 1950, with over 7,000 aircraft built in multiple variants. The wooden wonder served with distinction in dozens of roles and with air forces around the world. But the FB Mark 18 Tsetse remained unique, a specialized variant produced in tiny numbers for a specific threat that ultimately evolved beyond the weapon's capabilities. It was both a triumph of engineering and a dead end, successful in its limited role but too inflexible to adapt as the war progressed. For historians studying the Battle of the Atlantic, the Tsetse Mosquito is a footnote, a curiosity, an example of the desperate creativity that characterized Allied anti-submarine efforts in the middle years of the war. It doesn't appear in most popular histories. Aviation enthusiasts often don't know it existed. Even World War II documentaries rarely mention it beyond a brief aside. Yet for the men who flew it, maintained it, and died fighting it, the Tsetse was intensely real. For Werner Henke and his crew aboard U-976, it was the last thing they experienced before the ocean poured into their submarine. For Flight Officer Turner and his navigator, it was the weapon that gave them a fighting chance against targets that should have been invulnerable. For German U-boat commanders across the Bay of Biscay, it was one more reason to fear the grey skies above. The final mission, flown by a Tsetse Mosquito, is not recorded with any certainty. By May 1945, with Germany surrendering, the anti-submarine role had become obsolete. The remaining FB Mark 18s likely flew a few more training sorties, perhaps some coastal patrols, and then were grounded permanently. Within months, they were being stripped for parts or towed to scrap yards. An aircraft that had cost enormous sums to develop and equip was reduced to salvage. Some components were saved for museums, but these were primarily from standard Mosquitoes. The specialized Molin's guns were removed and returned to ordnance depots. A few ended up in collections or as display pieces outside military bases, but most were melted down, their steel recycled into the machinery of peace. The shells that had been manufactured with such precision, designed to pierce submarine hulls through water, were eventually fired as target practice or scrapped for their metal content. The photo reconnaissance aircraft that had documented U-976's sinking, the intelligence reports analyzing what had happened, the after-action reviews that tried to understand how an aircraft-mounted artillery piece could work so effectively underwater, All of these documents were filed away in archives. Many remained classified for decades. The full story of the TETSI program didn't emerge until researchers began combing through RAF records in the 1980s and 90s. What they found was a story of innovation, courage, and the razor-thin margins that often separated success from failure in World War II. The TETSI succeeded not because it was the perfect weapon, it clearly wasn't, but because it appeared at a moment when U-boat tactics made it viable. Had it been developed a year earlier, when U-boats were still diving immediately at the sight of aircraft, it would have been useless. A year later, when schnorkel technology made sustained surface operations unnecessary, it would have found few targets. But in that narrow window of 1944 to early 1945, when U-boats were fighting it out on the surface and the Bay of Biscay had become a contested battleground, the TETSI Mosquito, with its massive Molins gun, punched above its weight. It sank one submarine, damaged several others, contributed to the destruction of surface vessels, and most importantly, it shattered the psychological certainty that had sustained U-boat crews through years of war. The ocean was no longer armor, the crash dive was no longer salvation, and 57mm shells fired from a wooden aircraft could punch through a submarine's hull as if it were paper. These truths, learned in terror by the crew of U-976 on that March morning, spread through the U-boat fleet like a contagion. They undermined confidence, they made commanders hesitant, they added one more fear to the already overwhelming burden of men who fought beneath the waves. In the end, the TETSI Mosquito's legacy isn't measured in confirmed kills or successful missions. It's measured in the doubt it created, the doctrine it challenged, and the reminder it provided that even late in a war, innovation and daring could still change the game. For a weapon that sank exactly one U-boat, that's a remarkable achievement. And for Werner Henke and his crew, who died never understanding how a wooden aircraft could kill them beneath the sea, it was proof that in war, certainty itself can be the most dangerous illusion of all. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.